Hi, everybody, and thanks for joining us this week on Up in the Air. I'm Casey Laheka.
And I'm Casey Herman. There's so much we have to talk about this week: tornadoes, the Bermuda Triangle, and a feature on forecasting.
That's right. Transitioning into spring, we've seen some extremely high temperatures and low temperatures for this time of year.
Mike will stop by later with details on what we can expect with the weather moving forward.
We'll have all that and more in just a bit. But first, here's Update in the Air.
The legendary Bermuda Triangle is where ships go to disappear. New research off the coast of Norway may offer an explanation after all. Scientists at the Arctic University of Norway dove deep into the Barents Sea, and what they found could offer a viable scientific reason behind the Bermuda Triangle phenomenon. Multiple giant craters exist on the seafloor, an area in the west central Barents Sea, and are probably a cause of enormous blowouts of gas, researchers told the Sunday News. The craters in question are half a mile wide and 150 feet deep, the Daily Mail reports. The researchers think methane leaking up through the natural gas deposits caused craters, meaning there wasn't just gradual erosion, but explosions of gas as well. It would be enough to take out a ship or even an airplane flying overhead. The research does not prove that these gas explosions are common, let alone that they exist in the area that the Bermuda Triangle encompasses. This area is between Florida and Puerto Rico. Some say there's nothing mysterious about the Bermuda Triangle at all. The myths were exactly that. Others blame the strange disappearances on the region's tendencies for tropical storms. Still, the new theory is expected to be discussed when the study is released at the next European Geosciences Union meeting next month.
Have you ever wondered about the odds you'll experience a tornado in your area in any given year? Looking at this map, it shows the tracks reported of U.S. tornadoes from 1950 to 2014. The odds of being in the way of a tornado are much higher in the nation's midsection. Using data from 1980 to 1999, a study found a C-shaped area from Illinois to the high plains south to Texas with at least one tornado a day each year. Tornado threats vary during the year with the return and departure of warm, humid air. The probabilities of a tornado tracking over your lot are a lot lower depending on where you live, but being aware of the likely paths will help to keep you safe.
Human activity is playing a role in the dwindling size of Utah's Great Salt Lake, according to new research. While the research group acknowledges a role that climate fluctuations such as droughts and floods have played in the shift of the lake's water levels over time, the decrease in the lake size is predominantly due to human causes. According to the research, the heavy reliance on consumption of water uses have reduced the lake level by 11 feet and its volume by 48%. Drought conditions over the last few years have caused the lake's level to drop even more. About 30% of Utah has experienced moderate drought conditions, according to the U.S. Drought Monitor. Since the first pioneers settled near the lake in 1847, the lake levels have persistently declined. Salt Lake City is already facing serious air pollution problems, particularly during events known as winter inversions. The city experienced its worst air quality in years back in February. Low lake levels also threaten the habitat of millions of waterfowl birds. While the Great Salt Lake is not in jeopardy of disappearing anytime soon, decisions made now to preserve the lake's benefits and mitigate negative impacts for the coming centuries.
When we talk about climate change today, we have to look at what the climate was previously like in order to recognize the natural variations and to be able to distinguish them from human-induced changes. Researchers from the Niels Bohr Institute have analyzed the natural climate variations over the last 12,000 years, during which we have had a warm interglacial period, and they have looked back 5 million years to see the major features of the Earth's climate. The research shows that not only is the weather chaotic, but the Earth's climate is chaotic and can be difficult to predict. The Earth's climate system is characterized by complex interactions between the atmosphere, oceans, ice sheets, land masses, and the biosphere. Peter Ditlevson explains, we have only about 150 years of direct measurements of temperature. So if, for example, we want to estimate how great of variations that can be expected over 100 years, we look at the temperature record for that period. But it cannot tell us what we can expect for the temperature record over 1,000 years. But if we can determine the relationship between the variations in a given period, then we can make an estimate.
For those living in colder climates, the winter brings various hazards and annoyances from slick roadways to piles of snow that need to be removed quickly. Scientists, hobbyists, and university students are exploring new and exciting technologies to minimize human effort. When it comes to heavy snowfall, many of Japan's major cities top the list for some of the snowiest populated areas in the world. While industrial snow throwers are often used by governments, the average civilian also needs to remove snow. In the future, robots might be able to do all the hard work for you and could be more affordable. In addition to generating renewable energy, solar cells implemented on highways could help keep roads free of snow and ice during the winter months, reducing costs for transportation departments. Startup company Solar Roadways have been developing solar technologies that can withstand the weight of a car and can be used on roadways. Even though rock salt is still utilized heavily for ice and snow melt on roadways, some municipalities and transportation departments have been looking for an environmental-friendly alternative. In some parts of the country, a mix of beet juice and rock salt is being used to reduce environmental impacts from runoff, according to the Chicago Tribune. As of now, many of the futuristic technologies are not marketable to the public, but that hasn't stopped creative minds from coming up with new ideas to fight against the wintry weather.
Increased use of recycled water would help drought-stricken California in many ways, including giving residents a new potential health boost, research shows. California's current drought has inspired increased urgency for innovative solutions, wrote Sharona Sokolow and her colleagues. Sokolow is from the Fielding School of Public Health at the University of California, Los Angeles. Their study compared the impact of two state water conservation efforts. The first was banning landscape irrigation, and the second was expanding alternative water efforts, such as water recycling or removing salt and minerals from nearby seawater. Expanded use of recycled water appeared to have the greatest potential to reduce water and energy use and lower greenhouse gas emissions, according to the study's authors. Recycling water would also cut pollution and its associated respiratory problems. We'll be back in a moment with more. Thanks for tuning back in.
We now have a special feature on forecasting the weather and the difficulties that are associated with it. Enjoy.
Many people like to joke that being a meteorologist is the only job where you can be wrong half the time and still get paid.
And as millions of Americans found out while filling out their March Madness brackets and watching them crumble, predicting the future is hard, and it's something that meteorologists are tasked with every day.
Humans have been attempting to forecast the weather since ancient times. Ancient Egyptians were able to predict the flooding of the Nile River to be able to figure out when to plant their crops, and Babylonians were able to predict the short-term weather based on cloud appearance. Around 340 BC, the Greek philosopher Aristotle wrote Meteorology, a philosophical text that included theories about the formation of rain, clouds, hail, wind, thunder, lightning, and hurricanes, among other meteorological phenomena. This text was widely accepted until the late 17th century.
Computers, satellites, radar, and a coordinated network of meteorological observations has given forecasters access to data from across the globe. Numerical weather prediction began with Lewis Richardson's idea involving a stadium full of patrons and their calculators to solve fundamental equations of the atmosphere. Richardson's technique was not practical until the 1940s, when digital computers made it possible to solve the equations much quicker.
The ability to solve all of these equations quickly allowed for the creation of numerical weather models via these computers. Models such as the GFS and ECMWF are vital tools to the modern-day forecaster in providing guidance in making their forecast. Nowadays, the models are continuing to improve through the use of ensemble data to provide forecasters with better guidance. With the help of all of these technological advances, forecasts are more accurate now than ever before.
It's really amazing how much the weather forecast, and especially the weather forecasting models, the computer models, are 2 to 3 times as accurate now for a given forecast than we were when I was in your shoes and an undergraduate here at Penn State.
The Hurricane Forecast Improvement Project began in 2008 and has seen success since its implementation. Thus far, forecast track and intensity error has decreased by as much as 25% for the 1 to 5 day forecast.
Well, the benefits would be, can we better manage risk? And especially, can we better manage risk in an environment that we know where the climate is is changing.
NOAA has also upgraded the hurricane weather research and forecasting model, which has demonstrated a 10 to 15% improvement in forecast accuracy each year since 2012. And in 2014, it was the first model to accurately predict the landfall of a hurricane with the arrival of Arthur to the Outer Banks.
And the next revolution is going to be not only satellite data, but all these non-traditional data sources. So, all the way down to potentially things like this, like our smartphones, might start to be brought in to the next generation of weather models.
Going into the future, as computing power increases, so does the capability and accuracy of the weather models. But no matter how powerful and accurate the models get, there will still always be the need for a human forecaster.
But we do things that the computer models can't do. And ultimately, what we do better than any computer, my guess, certainly in my generation, and I'll bet in yours, we're creative. Computers are not creative. I think the role of the forecaster is going to keep evolving. I think the role of the forecaster becomes more into interpretation, communication, integration with the other disciplines, be it the business disciplines, emergency management, public safety. How do you interpret this? How do you interpret ensembles? Because ensembles don't make the uncertainty go away. They better characterize it.
Weather forecasting has come a long way over the years and is more accurate today than it ever has been.
And going into the future, it will only continue to improve and become more accurate. I am Julia Fike for Up in the Air.
And I'm Brian Mastro.
Thanks for tuning back in. It's now that point of the show where Mike is at the climate wall.
That's right, and as we gear towards the end of the month, Mike now has our March wrap-up.
That's right, Casey Squared. We're not quite out of March yet, but we're just about there. March 28th, and this is what we've looked at throughout the month. Our warmest high was 76 degrees, pretty comfortable, actually, but our lowest low was still pretty cold at 19 degrees. We had a fair amount of rain, and the rainiest day we had was 0.71 inches, and our snowiest day was 0.1 inches. We actually had that occur twice. Speaking of snow, we still have a fair amount of snow across the country. 14.1% of the country still has snow in it, but most of that is concentrated in the mountains of the west, the Rockies, and as we zoom into the northeast, Maine is our main contributor to snow in the northeast. Actually, a pretty large amount still up here in northern Maine, and not much to speak of in the rest of the northeast. Taking a peek forward into our next week's pattern in the upper air, most of it is going to be pretty, not much to speak about in the upper air, but a weak ridge does inch its way through the area, but nothing really much to speak of there. Taking a peek into our temperature outlook for next week, and April 5th to April 11th, most of the East Coast is going to be pretty cool. From North Carolina all the way up into Maine, we're expecting to see pretty far below average temperatures. Peeking forward into the west, however, it looks really good for the west. West of the Mississippi River is going to be very, very comfortable. I would like to be in this area in this point in time. Pacific Northwest, you're going to be pretty darn comfortable. Peeking forward into our precipitation outlook, however, it looks a little bit different. Michigan, Wisconsin, and then northern New England also looking to get a little bit more precipitation than average. Texas, however, there's a very, very dry area here in Texas that we're expected to have not much rain at all. However, taking a look into the Pacific Northwest, it's pretty dry, not far below normal, but pretty darn dry, pretty comfortable. And speaking of dry, here's our current drought monitor. It actually looks a lot better than it has in the previous months. California has really, really improved a lot. Southern California has actually gotten a fair amount of rain, and hopefully that continues on. But that's all I got at the Climate Wall. We'll send it back to Casey and Casey at the desk.
Thanks, Mike. Unfortunately, that's all we have for this week's show, but we'll be back next week with more, as always. But for now, I'm Casey Lehecka.
And I'm Casey Herman. We'll see you next week, Up in the Air.